All right. So what we're going to do tonight is finish up the sample midterm. This will be the second part of two parts. And when we're done here, I'll just post all these handwritten solutions. The typed up solutions are on Moodle anyway, but these are done by hand. So I don't know, maybe this will provide more insight along with the existing solutions. So we'll see how that goes. But these are the rest of the questions. These are pretty much all the derivatives questions where we use the rules. Although for the first one, we have to use the definition of derivatives, which means we're taking limits. Okay, so let's see how that works. God, where is it? Oh, here we go. Okay, so with 372, the actual question is, for the function 3 over x, what is the derivative? Okay, so here's what you're, oh, by the way, and it's not just what is the derivative. I mean, you're supposed to use the definition of derivatives. So in other words, f prime of x is the limit as h goes to 0 of f of x of plus h minus f of x all divided by h. Okay, so f of x plus h will be simply 3 over x plus h. All right, so let's do this. Let's make the substitutions. So again, this would be 3 over x plus h minus 3 over x all divided by h. Now, of course, as you can probably guess, if we directly substitute 0, we will wind up with the unfortunate result of 0 over 0. Okay, in other words, if those h's go to 0, you'll see you're just you have 0 in the denominator. And in the numerator, you would have 3 over x minus 3 over x. So obviously, we have to do something to reduce the complexity of this expression. So what we'll do is for the numerator, we'll multiply the first term by x over x. And in the second case, the second term, we'll have x plus h over x plus h. All right, so what does that give us? So here we have 3x over x plus h minus 3x plus h over x plus h. And now we can simplify it a little. We can drop the parentheses in the right-hand side. And of course, that leaves us with negative h over x plus h. Now that's just the numerator. So for the entire expression, in the numerator, we have minus h over x plus h. And in the denominator, we still have h. Okay, so we can rewrite this as minus h x plus h. So dividing by h is equivalent to multiplying by 1 over h. We have a cancellation here. Ooh, wait a minute. No, sorry, I did something terribly wrong. You know what it is? This should have been minus 3h. Oh, I knew it. Okay, let me fix that. See, this is the nice thing about writing it by hand. Look how easy that is. Yeah, see, in other words, it's not just a negative here. Minus 3 times x plus h in parentheses is minus 3x minus 3h. So the two 3x's drop out. I've got minus 3h here. Same thing here and here. Whoops. Okay, now these h's do drop out. And I'll be left with minus 3 over x plus h. Now I can directly substitute x plus 0. So I end up with minus 3 over x squared. And that is the correct answer. But we found it by using the so-called definition of derivatives. In other words, when they say that, they mean using the limits. Okay, so instead of the rules, which we've been using, they want you to go through all the steps where you actually prove that the limit equals, the derivative equals the limit as h goes to infinity, 0 of f of x plus h minus f of x all over h. Okay, now the rest of these are just rules. The thing is, it's good to know how to do this definition, but once you've done it once or twice, there's really no need to keep using the definition because the rules are designed to make things a lot quicker. So for example, the next one should be 374. Here we've got the function is 4 minus x squared, all raised to the third power. So this one requires us to use the so-called generalized power rule. Which, as you recall, is this. If f of x equals g of x raised to the nth power, then f prime of x, actually, I'm going to run out of room there. Hold on, let me move it. It's going to be n g of x raised to the n minus 1 power times g prime of x. Okay, so in this case, we would say that g of x is 4 minus x squared, and g prime of x, based on the power rule, is just negative 2x. Okay, so we can plug these in, and of course, n is 3, as you can see up here. So our final answer will be 3 times the original function, 4 minus x squared, raised to the 3 minus 1 power, multiplied by minus 2x. And when you combine these, you'll end up very simply with minus 6x, 4 minus x squared, raised to the second power. Now, I mean, the square brackets are not necessary. I could rewrite it like this too. Sometimes the square brackets are good for when you really need to simplify or make it easier to see that there might be multiple expressions, some of which are very complicated. Okay, so that's what I needed to do there. So what comes next now? 376 asks us to take the derivative of natural log x plus 2. Okay. Now, what rule are we looking at here? All right, you might recall that if f of x is the log of f of x, g of x rather, then f prime of x is g prime of x over g of x. So in this case, g of x is the x plus 2, and therefore g prime of x is simply 1. Okay, so we just end up very simply with 1 over log x plus 2. Oops, no, sorry, not my 1 over x plus 2. You don't use the log. Okay, in other words, g of x is what's in parentheses, 1 over x plus 2. All right, so that's done. Now this next one, number 378, the function is f of x equals radical 3x squared plus 2. And of course, as you know, that can be rewritten in a slightly different way. We can think of this as f of x equals 3x squared plus 2 to the 1/2 power. And once again, we're basically looking now at the generalized power rule, which we can see up here. Let me just copy this. And of course, this time, g of x is what's inside the parentheses, 3x squared plus 2. g prime of x is 6x based on the power rule, and n is 1/2. So we know that the derivative f prime of x from what we saw earlier is n g of x to the n minus 1 g prime of x. And so direct substitution means we have 2, 3x squared plus 2 to the 2 minus 1 power all times 6x. And that reduces to 12x, 3x squared plus 2. We don't have to write the exponent of 1. It's understood. Okay. Now, oh my God, I just realized I screwed it up. No, n is 1/2. I'm sorry. I couldn't see it, and so I wrote the wrong thing. No. This is wrong. It should have been 1/2. That's what I get for not scrolling it back up again. Okay. So that makes a big difference because now look what we have instead. Yeah, no, that's right. But now we can simplify it a little bit. We know that 1/2 times 6x is just 3x. But if you want to simplify it a little, what you can do is just rewrite it as 3x over the square root of 3x squared plus 2. Now we're good. Okay, and that, I think it does look kind of nice compared to negative 1/2. But either way, you've got the right answer. All right, now this next one is going to be a nightmare. I'll tell you right up front. Well, I shouldn't say a nightmare because it involves a rule that we really only looked at once. It's actually combining two tricky strategies here. We have x squared y equals y plus 2 times, plus xy sine x. So there are two things going on here. Number one, we'll have to use, because of the way it's written, implicit differentiation, because realistically you can't separate out the y's and put them on one side of the equation. But there's another thing going on here too. Whenever you have something like this, a product of three functions, there's a rule for this, which we only briefly mentioned. And what happens is k prime of x consists of, we have first f prime of x, g of x, h of x, plus f of x, g prime of x, h of x. And then finally we have f of x, g of x, h prime of x. We're going to need that for this term right here because you're multiplying three terms together. Now, by the way, let me remind you quickly that with implicit differentiation, we are assuming that y is a function of x. Okay. I mean, we usually assume that anyway, but it should be clear that that y is considered to be a function of x. So that's why it counts here. In other words, x is a function of x, y is a function of x, sine x is a function of x. That's why we need to resort to this rule. So why don't we analyze that first? Let's start with x, y, sine x. K of x equals, this is f of x, this is g of x, and this is h of x. So f of x is x, f prime of x is 1. All right. G of x is y, which implies that g prime is dy dx. And then, of course, if h of x is sine x, you'll recall that the derivative of that, is the cosine. Okay, so this long expression ends up looking like this. Actually, let me do this. Let me see if I can split up the screen a little bit. Oh, God. Oh, no, it's doing exactly the opposite of what I want. I don't know about you guys. I can't stand it when I can't see the ribbon. And now I'm not sure how to get it back. There's used to be like a little pin symbol. I can't seem to find it. That's very annoying. Especially with this thing in the way up here. This really kind of causes, oh, Jesus. Okay, maybe I fixed it. Okay, good. All right. I really do need to see that thing. All right. No, I wanted to split the screen, but this tool, oh God. This toolbar here really gets in the way. Okay. All right. Oh, Jesus. All right. You know, this is why I love technology so much. All right. So view split. All right. So this is what we're actually doing right here. All right. So we're looking for K prime. Okay. I guess this thing is. All right. So f prime of x is 1. Then we have y sine x. We have x dy dx sine x. And then we're going to have for the last term xy cosine x. So in other words, in this expression up here, just this xy sine x, its derivative is what we just saw here. Okay, so when we get the whole thing together, remember, this is still implicit differentiation. Okay, so how do we treat this? All right, so here's what we end up doing. Now, here we have a product rule. The derivative of this with respect to x is going to be using the product rule this. Okay, in other words, you've got the first times the derivative of the second plus the second times the derivative of the first. Now, this one is easy. This is just dy dx. All right, so we have everything we need. So finally, result of this catastrophe. Let's do this. Okay, well, this thing is determined to be annoying. I'm probably stuck with this forever. It will never go back to the way I wanted it, but we'll see how that goes. All right, so finally, we can put all this together. Oh, wait, no, sorry, hold on. No, I did something wrong here. Hold on. Okay. And then this last part, I'll just put it all down here to save space. So we've got a few dy dx's floating around here. So I'm going to get them all onto the left-hand side. Everything else on the right-hand side. And over here on the right-hand side, we'll have this 2xy minus, that is, plus y sine x plus xy cosine x. And so now you can see what we're going to do. We're going to factor out the dy dx from the left-hand side. And finally, this nightmare will be over because we'll just divide both sides by what's in the brackets. I'll tell you what, I think we'll refrain from the pleasure of having one of these on the actual test. I think that that is kind of pushing it. You know, it's you can prove that you know this stuff without necessarily having such horrifically complicated problems. So yeah, I kind of picked that one maybe by mistake, but it's good to have some practice with these terribly complicated ones. But yeah, I think we'll tone it down a little for the actual midterm. All right, now number 382 is, oh, now this is interesting. We're being asked to find the third derivative for f of x equals, oh boy, 3x plus 2 squared. Okay, so you're basically applying the generalized power rule 3 times. Another nightmare. Okay, now remember how this works. This is your g of x. F prime of x is n g of x to the n minus 1, g prime of x. So if this is g of x, luckily g prime of x is simple. So and n is 2. So what will we have? The first derivative will be 2, 3x plus 2 to the first power times 3. Or very simply, and now here, because it's so simple, we can just rewrite this as 18x plus 12. So the second derivative will be a breeze because you've only got to one term with an x. And then that'll just be 18 based on the power rule. And then the third derivative is simply 0. Okay, so any polynomial you encounter, sooner or later, the derivative will be 0. Okay, because you'll keep losing exponents as you go along. All right, 384. Oh my God. Okay. The arc cosine of x plus x. Now we're supposed to find the tangent line, not just the slope of the equation of the tangent line at x equals 0. Now, you recall there's a chart in our slides. Let me just show you that when y equals cosine -1, or cosine, the arc cosine, dy dx. And you can look this up for yourselves, but it's -1 over radical 1 minus x squared. So the first derivative here, f prime of x, or dy dx, is just -1 over radical 1 minus x squared plus 1, because remember there's an x in here. So because we're trying to figure out the equation of this tangent, we're starting out by looking for where the slope is 0. And so we end up actually with 0. Okay. Now, as far as the entire equation is concerned, the equation of a straight line means that we need a slope. And in order to find the intercept, we need a single point. Okay, so now here's where it gets interesting. F of 0, it turns out, would be the arc cosine of 0 plus 0. And that turns out to be pi over 2. Okay, so in other words, the point 0 comma pi over 2 is on this curve, or it is the is on the tangent line. So therefore, by the way, pi over 2 is approximately equal to about 1.57. So we'll have pi over 2 to solve for b. We have pi over 2 equals b. So the equation is pi over 2 because m is 0. So it's a straight line. Okay, wherever it is. Now, you might look at it and say, well, what a weird result. So what I'm going to do is go to Symbolab, and we're going to grab this graph. And when you see it, I think you'll agree that it looks right. Okay. So we'll have y equals. So it's the, we can, in Symbolab, you can write this as the arc cosine. Sorry, of x plus x. Now we're getting somewhere. Now look at this thing. Oh, you know what I just realized? I'm using a different computer than I normally do. I don't have my that software that I use. I forgot what it's called already, but the software that I normally use, Snagit, that's what it's called, to copy and paste. So I can't do it, but I can show it to you. And you can see right here at the intercept, this is where the tangent line is, and you can see that it's flat, so the slope is 0, and it intercepts right there. And Symbolab is helping us with this and showing us that, in fact, this is pi over 2, which is approximately 1.57. Okay, so that's why we get this result. Okay, so anyway, that's that one. But yeah, I mean, you can go look at it on Symbolab. I just can't copy and paste it on this computer because I just realized I didn't buy Snagit for this one. This is my travel computer. It's not my main computer. This is the one where if it gets lost, it's like whatever. All right. So, oh my God, it just suddenly occurred to me, that was it. We're done. So that was it for the sample midterm. So you can see it's not that difficult. So what I'm going to do is put together the real thing in the next day or two. And I think that under the circumstances, you can have a couple of weeks to get it done, especially because we have holidays coming up. And so I'll let you know. But right as of right now, by watching this video in part one of this, and or reading through the solutions that I've typed up, you should really have no trouble following what we've done. Okay, so I'll post this and the second video on Blackboard, sorry, Moodle. And then as soon as I can, I'll post what's next, which is chapter 4B. We're waiting for 4B. That's right. Okay. It's a very complex but very important section of the course. So we don't want to rush through it too fast, but I want to make sure you have a look at it as soon as possible. So anyway, so I'll just stop it right here, and I'll post this and as soon as it's done. And then I'll be back with you very soon with my recording of section 4B. Okay, so I'll see you pretty soon.